The pH scale for acidity is defined by the formula pH equals negative log base 10 of H positive, where H positive is the concentration of hydrogen ions measured in moles per liter. Write your answer as a decimal or in scientific notation, accurate to at least 3 non-zero significant figures. Do not use the calculator E notation for your scientific notation. Alright, so part A. The pH of human blood is 7.4. Calculate the concentration of hydrogen ions in moles per liter. Okay, so to do this, we have to take into account that the formula given is pH is equal to the negative common log, and I don't need to write base 10 because that's understood, of this value, which is the hydrogen ions and moles per liter that we're looking for, so H positive. Just think of it as a variable. It could just be X. That's fine. All right, the pH is given. The pH is given as 7.4, so I'm going to substitute that in, and that gives me 7.4 equals the negative common log of this value, H positive. Next, we'll divide both sides by -1, and that will get the logarithm by itself. So I have log of H positive equals negative 7.4. And I needed to get that logarithm by itself because the thing is, I have a variable for the argument of the logarithm, and there's no chance that I'm going to be able to solve for that as a logarithm. I need to switch it over to exponential form. But I have to have it very specifically. A logarithm with no multipliers of a value is equal to a constant in order to make that change. So now I'm in a log form right here. If I change it to exponential form, I need a base, and since this is a common log, the base is 10. The exponent is negative 7.4 because the result of a logarithm is always an exponent, and that's equal to H positive. So this is now in exponential form. And I can easily solve for this value H positive by using the calculator to come up with whatever 10 to the negative 7.4 power is. So let's open up the calculator and see what we get. So 10 raised to the negative 7.4 power. Do be careful and don't put a minus 7.4 because it distinguishes a negative from a minus. And here we are. So for three significant figures, this would be 3.98 times 10 to the negative 8 power. This E right here, that's the way the calculator represents scientific notation, but it specifically told us not to use that as our final answer. And it's simple enough. We just change that E out for the times 10 raised to whatever power is given. And then that right there is our final answer. So 3.98 times 10 to the negative 8. Now, where there is a part A, there's probably a part B, so let's scroll on down. And here we're told that the pH of vinegar is 2.2. And we want to calculate the concentration of hydrogen ions in moles per liter for this pH. So we do the same thing. All right, so pH is the negative common log of H positive, that value that we're looking for. And in this case, the pH is given as 2.2, and that's equal to the negative log of this H positive value. If we divide both sides by -1, then we have negative 2.2 is equal to this common logarithm of the value that we're looking for. And we can't solve it as a logarithmic equation because the variable is in the argument of the logarithm. So we need to change this over into exponential form. So we have a base of the logarithm as 10. It's just understood for a common logarithm. Raised to this exponent of negative 2.2, and that's equal to H positive. And that we can put into the calculator in order to get a value. So 10 raised to the negative 2.2 results with 0.006 as an answer. And it would be fine actually to write that as 0.006 because you can write as a decimal, but it does say to use 3 non-zero significant figures, so it might actually not accept it unless you have a few more decimal places, like 631, for instance. I think then it would accept the answer because then you have the non-zero. I don't know if it would see these as significant figures or not, but this it would definitely accept. And the reason I say that is because what it would be looking for in scientific notation would be 6.31 times 10 to the negative third power. So to get three significant figures, you would need the 3-1 on there. So that's why I'm thinking you probably would need at least that many to work it, to get the answer to work. So just be careful, that's all.